Now on to the demonstrations. Turn on the acetylene regulator. Set it to the required pressure. Just refer to the manual. Turn on the oxygen regulator and once again set the required pressure. Make sure all connections are tight and do not leak. Connect the welding mixer complete with tip. Before lighting, make sure you purge. This clears the system of mixed gases. Note that the flash guards are a big help in keeping the integrity of the system. Turn the acetylene valve on. You only need a little. Light the gas. Turn it on more till the black smoke disappears. Then back off till you get a little black smoke. This is about right. Now turn on the oxygen. Notice we start off with a carburizing flame with a long feather, and it is reducing to a neutral flame with the feather just gone. Any more and the flame will become an oxidizing flame, a short, harsh, loud flame. Note this type of flame is unstable and more prone to flashback. The demo here is oxygen-acetylene fusion welding of mild steel. Note the angles of the tip and torch. We first develop a molten pool, then add filler metal. Once you master this technique, you're ready to do any welding job. You get the feel. Practice is the key. Oxygen-acetylene are the only common industrial gases that can fusion weld mild steel. Brazing and silver soldering are similar, but you're not bringing the parent metal temperature up to a liquid state. Dull red would be a good description. Now let's move on to cutting.
It's a neutral flame that's needed 99% of the time, but a common trap for operators is when they're cutting a thick piece of steel is to turn their oxygen up, which gives an oxidizing flame, which becomes a safety and performance issue. A flat seating tip has a great advantage when you're changing it. It doesn't need to be tightened with a 10-pound hammer or a big shifter. It's easy to undo and it's easy to tighten. Another suggestion came up from an operator was in that we build into the cutting valve, in the fact that it's got a lot of travel in it. It's a bit like a variable speed drill. You decide how much cutting oxygen you want to bring in. You bring in a little or bring in a lot, it's your choice. There's a lot of travel in the cutting valve, making it a lot easier for the operator to use. As mentioned previously, the real difference is in the mixing accuracy and the flame shape. Get these two areas right and the whole thing is a lot easier and a lot quicker to use. It's a little bit like a carburetor of a car. Get the mixing right and the jets right and the whole car feels totally different. The rev heads out there will know what I mean. We're after a neutral flame, same as we had before, and that'll make it a lot safer and give us the right performance.
Watch how quickly we heat up the edge. That's the Harris difference. The tight flame pattern, superior flame shape, and because we keep the cutting oxygen pure, away from the mixing chamber, we get fast cutting, time after time.
Here we are, ready to gouge just by changing the tip.
Once again, see how quick we punch the heat in. But the thing to remember is that oxygen-acetylene uses up the surrounding oxygen. Heat rising from the job can deflect away the atmosphere, which contains oxygen. That's why sometimes you need to adopt an in-out technique. Notice it's quick and you develop a feel. This could need to be more pronounced in tight areas, for example a T-joint or a U-joint. The speed and quality is governed by the same factors as cutting, flame shape and oxygen purity.
Heating is another application often used today for bending steel, undoing a seized nut, those types of things. We're going to now show you heating.
Set your pressure as per the manual, but the important element is to keep the pressure as close to equal as possible. Increasing the oxygen pressure beyond the acetylene pressure can lead to an oxidizing flame, which we know is unstable. The common trap is operators set it at the same position on the gauge. For example, 2 o'clock could be 150 kPa on the acetylene gauge. The same position for oxygen will be 1000 kPa. The amount of heat you develop is governed by how much gas you burn. Using small bore 5mm hose seriously limits performance and greatly increases the risk of a severe flashback. Notice we are using twin 8mm hose for a 60% increase in flow. When you light the flame, it's the same principle. Neutral is the desired option. Watch the actual heating technique. We hold the tip close, flames about 3mm off the plate to start with. As the metal gets hot, deflecting heat up, we lift, tip and rotate, ensuring the surrounding atmosphere can get at the flame and complete the combustion process. Acetylene should not be drawn from the cylinder quicker than the filling time. That is 1 cubic metre per hour. For example, a G-size cylinder should last 7 hours of heating.
In this video we've shown you oxyacetylene welding, brazing, the cutting process, the gouging process and oxyacetylene heating. We believe if you use it the Harris way, you're going to get superior performance, gas savings and a much safer system. In the tips and the tape, the instruction manual, you're going to maximise the performance out of your tool. That's it for now. Thanks for your time. Bye.
Now we come to the method of grinding the surface at the end of the rail. Turn the feed adjustment handle on the end surface grinding equipment clockwise until you are no longer able to turn it. Then adjust the 4 setting pieces so that they are all in contact with the rail and set the grinding wheel approximately 2 millimeters from the rail. Tighten the clamp handle. By turning the feed adjustment handle anti-clockwise, start the grinding wheel and move it forward until the wheel touches the rail. As soon as the grinding wheel touches the rail, gradually turn the feed adjustment handle anti-clockwise and move the wheel up and down to grind the end surface of the rail perpendicularly. After you have finished grinding, check that the ground surface is exactly perpendicular to the axis of the rail. Then set a square against the end of the rail and check the clearance between the rail and the square. Confirm that the longitudinal clearance is less than 0.25 millimeters and that there is no transverse gap. If the clearances are larger than these tolerances, then you must grind again. After checking, remove any remaining burrs on the rail with a hand file. Now we're going to ignite the burner and then adjust the flame. Please ignite the burner at least 50 millimeters away from the point where the 2 rails are to be joined. If the burner is ignited too close to the point where the 2 rails are to be joined, black smoke will affect the integrity of the pressure weld. Once you have ignited the burner, you can move it to the point where the 2 rails are to be joined and adjust the flame. For pressure welding of the rails, we would like to draw your attention to the following. During the initial heating phase, under no circumstances should you remove the flame from the point where the 2 rails are to be joined. After a short space of time, the part to be joined is moved toward the fixing frame. It is therefore necessary to move the position of the heating spot accordingly. As the surfaces in contact with the flame may swell, you should keep heating and rocking the burner so as to prevent the bottom part of the rails melting. We recommend you rock the burner in such a way that the flame focus scanning area is approximately 20 millimeters to the left and right of the point where the 2 rails are to be joined. Should you notice bending of the bottom of the rails despite rocking the burner, it will be necessary to insert buckling jigs beneath the rails and lift the rails up until the bottom part of the 2 rails again lie flat and in line. You can now prepare to trim the rail. When the remaining pressure welding thickness reaches 3 millimeters, remove the refractory panel on the bite side. Then push the upper bite inward until the bite holder pin is locked. When the amount of pressure welding to be done reaches 0, stop the pressure welding and move the right-hand side clamp cylinder backward. Then release the chuck that has bit into the rail. Turn the manual pressure welding selector valve to pull for an instant, then immediately switch to pull. Turn the pressure selector switch to the trimming position. After this procedure, turn off the burners and remove them. When the trimming pressure reaches 0, immediately cease trimming. Then remove the bite holder pin and move the trimmer backwards.
Better. Very nice.
Go ahead and open it.
Bent back, your oil line. Just showing that we have our air stuff on the ceiling.
Cool looking.
That's a little better, Garth. Yep.